Hi, I'm Maxine Ticala, and today I'll be discussing John Husper's An Introduction to Philosophical Analysis, Chapter 4, Section 5, David Hume's The Problem of Induction. If Leni Robredo is a Philippine presidential candidate, and all Philippine presidential candidates must be at least 40 years old or older, then Leni Robredo is at least 40 years old or older. This argument is called Inductive Reasoning, where the conclusion is logically deduced from the premises. If the premises are true, then the conclusion must be true. Another example, if all people in Manila hostage were killed and Marites was in Manila hostage, then Marites was killed. This doesn't prove that Marites was killed. She might not be in the hostage, and perhaps not everyone in the hostage was killed. Maybe she was able to escape. But we can only make a prediction that she was killed if the premises state that all people in Manila hostage were killed and she was in there. Now that we know what deductive reasoning is, let us now move on to inductive reasoning. In the past, every time I would put my hand near a flame, I would feel the heat. Therefore, I will feel the heat the next time I put my hand near it. This is an example of inductive reasoning. It is where a person observes something that has always happened in the past and infers that the future will behave in the same way, or the future will resemble the past. Let us have another example in the form of an argument. I dropped a pen 1,000 times, and it also fell to the ground 1,000 times. Therefore, the pen will fall again the next time I drop it. We can see here that unlike in deductive reasoning, the premises here only provide evidence for the conclusion. They make the conclusion more probable, but not certain. It has happened thousands of times in the past, and we consider it as evidence that it will continue to do so in the future. However, not everything that has occurred repeatedly in the past can be taken as evidence that it will continue to occur in the future. Let me give 4 examples. A baby has been breastfed every single day for 2 years. The mother doesn't consider it probable that the baby will continue to do so for the next few years. She knows that she needs to introduce other food to the baby. And as the baby grows into a child, into a teenager, and into a grown man, the person becomes too old for breastfeeding. In past centuries, people communicated by sending letters to each other. If you have lived 100 years ago, you will probably think that letter writing will continue to be the form of communication if you saw no alternative. But if you had noticed new inventions such as the internet, telephones, and smartphones, you would say that new inventions will probably replace letters because the new inventions are faster and efficient. Every relative of mine who was born in a day ending in 1 died due to COVID-19. We wouldn't take this as evidence that my other relatives who are born in a day ending in 1 will also die due to COVID-19. It is because there is no connection between the event, dying due to COVID-19, and the numbers attached to the day. Vico Soto, who is 32 years old, says that he has come out of his sleep alive 32 times 365 nights, and that therefore it is highly probable that he will awaken tomorrow morning after his sleep tonight. But then, Juan Ponce Enrile, who is 97 years old, says that he has even more evidence that he will be alive tomorrow because he has the evidence of 97 times 365 nights. We cannot say that Juan Ponce Enrile is more probable because the greater number of years doesn't by itself provide evidence. We know that at his age, he is less likely to function well compared to a younger person due to cellular deterioration and diseases. We see that if it's a law of nature, we expect it to continue to operate in the future. This is because a law of nature is defined so as to be open-ended, meaning it has no determined limit or boundary. Therefore, if it stopped in the year 2000, it wouldn't be a law of nature. However, this doesn't prove that there are any uniformities that extend into the future. We can say that law will continue to operate in the future because that's how we define law. We can define words however we will, but there may be nothing in reality that corresponds to our definition. Maybe there are no laws of nature in the sense we require. Let us review the 2 sources of knowledge. Number 1 is relations of ideas. These are necessary truths, and they're discoverable by the mere operation of thought. We don't need to go out and gather evidence just to know they are true, while on the other hand, matters of fact are claims grounded on experience in the world. In order to know if it's true, we have to go out and make some observations. So, how can we know something if it's not by mere operation of thought and by observations? What we do is we use induction. We use our observations from the past, such as regularities, as evidence to infer that it will continue to do so in the future. However, David Hume had a problem with this kind of reasoning. He thinks that if we make inductive arguments, we assume that the nature is uniform. There is a principle called the principle of uniformity of nature, which states that law X has held in the past, therefore law X will hold in the future. He thinks that we're simply observing the regularities of the past and we're projecting these regularities onto the events of the future without any justification for it. He said that we use inductive reasoning because of habit and custom. We do it out of instinct. He called these customary conjunctions because they're events that we've become accustomed to see happening one after the other. We've always seen a pen falls after we drop them, and we've always experienced pain when we accidentally cut our fingers. But according to Hume, that the order of events will not always be the same. Just because two events are constantly conjoined together does not mean that they have necessary connection. So, in order to justify inductive reasoning, we should prove that nature is uniform. But even though nature has been uniform in the past, how can we prove that it's going to be uniform in the future? One may argue that nature has always been the same in the past, therefore it's going to be the same way in the future. What we are doing here is we use induction to justify induction. They're the same concept. We use our observations from the past as evidence to infer that it will continue to do so in the future. We are left in a circular argument because we are using induction in showing that we can justify using induction. In conclusion, David Hume thinks that there is no legitimate reason why we assume that nature is always going to be uniform, even though it has always been in the past. However, inductive reasoning helps us make useful predictions about the future even though it is not 100% certain. Now, let's move on to Andresito Acuña Philosophical Analysis, Unit 4, Module 3 and 4, on Induction and Generalization. In philosophy, the term induction is ambiguous. The epistemologists use the term induction to refer to a general principle which states that events in nature are regular and not random. This means that the future, although not a carbon copy, resembles the past. In the language of John Stuart Mill, an assumption with regard to the course of nature and the order of the universe, namely that there are such things in nature as parallel cases. Every case of induction involves this assumption. When we look at the actual course of nature, we can see that the assumption is justified and the course of nature is uniform. This principle is the basis of all empirical statements. This allows us to connect one event with another. Without this, events will be isolated, unconnected, and unrelated to one another. This principle also allows us to compose an argument using observed premises to an observed conclusion. In order to be part of what is meant by inductive reasoning, any type of empirical argument must contain a reference from the observed to the unobserved, from known to the unknown, or from the familiar to the unfamiliar. The inductive argument should have a conclusion that is made probable on the basis of the truth of the premises. We should analyze its content to appraise its logical quality. Doing this is much more difficult and complex because even though there are patterns of inductive reasoning, these patterns will not guarantee the logical quality of the argument. In order to know what is it like to argue from the observed to the unobserved, let me give you an example. You have 100 marbles inside the box. Then, you are provided with the information that all marbles have the same size, weight, and brightness, but what you do not know is their colors. First, you get a sample from the box to determine the color of all marbles in the box. To make sure that all marbles in the box will have an equal probability of being chosen, you randomize it by shaking the box. This will assure that your sample is representative of the whole. Suppose that the first marble drawn is white. One white marble is the required evidence for the truth of a singular statement. A marble is white. Now we have the complete evidence for the truth of a claim. A marble is white. And indirect evidence for the claim a few marbles are white. We can see that in the few claim, we have made an inductive inference from the observed to the unobserved. If we have 10 white marbles, many claim becomes certain and most claim becomes probable. If you have 30 white marbles, many claim is certain and most claim becomes highly probable. Then almost all claim becomes probable. If you have 80 white marbles, many claim becomes certain, most claim is certain because it means that most must have at least 51 marbles. Then almost all claim becomes certain if almost all means 80 and true beyond reasonable doubt, or very high probable if almost all means 80 to 90. Then we have all claim that becomes highly probable. If you have 99 white marbles, you can say that many claim, most claim, and almost claim becomes certain, and then all claims becomes true beyond a shadow of doubt, but it is not certain. The evidence of 99 white marbles will not make the last marble white. The last marble may turn out to be a different color. One counterexample will destroy a universal claim. It is easier to falsify than to verify a universal claim. To recap, the required evidence of some is at least 1, and the required evidence of many is at least 10. The required evidence of most is at least 50% plus 1. The required evidence of nearly all or almost all is 80 to 90%. And the required evidence of all is 100% or complete enumeration. On the other hand, the claims of few and several are claims that are systematically vague, which means that their domains would change depending on the context. In conclusion, when you have complete evidence to confirm your generalization, you have not made an inductive inference. The element of arguing from the observed to the unobserved or from known to unknown is missing when you have the complete evidence to support a claim. Now let's move on to Unit 4, Module 4, which is entitled Generalization. All crows I've seen are black, therefore all crows are black. The evidence here is all crows I've seen are black, and we know that it is true because on 5 different occasions we have seen about 50 crows. But we also know that the required evidence of 100% or complete enumeration is needed for the conclusion all crows are black. However, this complete enumeration is physically impossible to produce. According to Acuna, maybe Karl Popper is right, that there is no need to verify. Instead, we should falsify by looking for a counterexample. Example of this is a crow that is not black. But falsifying all claim is as difficult as verifying because in both cases we are looking for a crow that is not black. This is because we do not know how many crows there are in the world. Also, completely verifying this universal generalization is very difficult. The claim is knowable and provable in principle. This is because if we have unlimited resources, we could commission simultaneous investigations in every possible place in the world where crows could be found, so that you could do a complete enumeration of all crows to discover if all of them are colored black. As a general rule, most universal claims do not have the required evidence to completely verify their claim. Therefore, you should only use a claim that evidence warrants. Example, if you are uncertain about the evidence but you want to make a generalization, you may use the term many. Then, the argument will become, all the crows I've seen are black, therefore, many crows are black. No one may disagree with you. On the other hand, if you claim most crows are black, then you will be required to produce 50% plus 1, and since you do not know the exact number of crows, then you cannot produce the required evidence. There are 2 requirements of a good generalization. Number 1, the observed cases or sample must be representative of the whole class or population. This requirement is difficult to satisfy because it is circular. We can't really know if the sample is representative of the population unless we completely enumerate the whole population and then compare it with our sample. They say that to ensure representativeness, we should randomize our selection of sample. This gives each marble an equal probability of being selected, thus making our sample representative of the whole population. However, we can only approximate it, instead of getting the requirement that the sample is representative of the whole population. Number 2, no conflicting case has been observed. This only means that a single counterexample will falsify a universal claim. Your teacher discovered that a student cheated in the exam. Then he concludes, without further investigation, that the whole class cheated. This shows a fallacy of hasty generalization where the characteristic of a single student was projected to be the characteristic of the whole class. The teacher has not internalized the epistemic application of not accepting a statement or conclusion to be true unless you have sufficient evidence for it. Another example of this is the root of a superstitious belief, where a mother believes that the albulario is the cure to a certain illness just because her child got better after they have checked. The hazards of making a hasty generalization shouldn't keep us from making one. Instead, what we should do is to hesitate to accept a generalization as probable until we have tested it for reliability. In making your own generalization, we should satisfy these 3 guidelines. Number 1, are there any cases to support a many claim, a most claim, an almost claim, or an all claim? Your generalization becomes more reliable if the number of your sample is closer to the required evidence to establish the claim of your conclusion. Number 2, have the observed cases been found in every possible variety of time, places, and circumstances? To confer more confidence in our generalization, we should have a wider variety and more random selection. Number 3, has a thorough search been made for conflicting cases? A more thorough search places more confidence in the generalization as it seems to resist falsification. All white cats with blue eyes are deaf. If we're going to analyze the statement, this doesn't satisfy the 3 guidelines mentioned earlier. We don't know the total number of cats with blue eyes, we don't know the number of samples taken, and we don't know the varieties of time, places, and circumstances of the observation. But if Darwin can discover the causal connection between the said characteristics, then this will strengthen the empirical generalization. Since Darwin proved this generalization, it has now acquired a qualitative change. Its truth no longer requires more empirical samples for its strength. And that ends my discussion. Thank you for watching.